Hey, this is Steve from the Tech Circuit. I posted this resistor network problem in my group, and the question was, what is the resistance from point A to point B? And I got a lot of different answers from group members, which was great. I mean, what fun would it be if everybody gave the same answer? There would be much point in posting something like this. It also means there's an opportunity to learn. Now, you may not run across this in the field, but I think understanding fundamentals like this will help you better understand how electronics works in general, and I think that translates to improved troubleshooting capabilities. Anybody can do a problem like this. I think just working with electronics a few minutes a day here or there, watching some videos, joining some of these electronics groups, and pretty soon I think something like this will become second nature. So the best way to approach this is incrementally. First thing that jumps out to me is, in looking at this, is this 3 ohm resistor and this 2 ohm resistor, well, they're shorted by a wire. So anytime that happens, those resistors go away because current it will favor the path of least resistance, and there's no least resistance in zero. So these resistors actually become irrelevant. So that leaves us with this here. We actually end up with these having gone away, we end up with this schematic, which is a 4 and 6 ohm resistance in series, and that's in parallel with a 10 ohm resistance. Well, these two add together since they're in series, and we end up finally with this. So this is our simplified circuit. We have two 10 ohm resistors in parallel, and that is in series with a 4 ohm resistor. We need to figure out what the parallel resistance equivalent is. Well, you can just plug it into the formula. It's a really simple formula. And if I do this, it comes out to 5 ohms. Now, if you're lucky enough for these two resistors to be equal, and I think this is why some of the group members were able to just look right at this and know the answer right away, is that you take this resistor and divide it by 2. So you have two resistors in parallel. You take any of the resistor values in that network, in that parallel circuit, divided by 2, and that's your parallel resistance, which is 5 ohms. And so, well, that leads us to this here, which is a 5 ohm resistor in series with a 4 ohm resistor, and of course, that equals 9 ohms. And that's the answer to the problem is 9 ohms. Now, let's go back to this here. This seems to be a topic of confusion and debate, is why do these 3 and 2 ohm resistors go away? Well, again, the current is going to favor the path of least resistance. Let's just plug this into the formula, but the problem is with 0 ohms, you can't plug that in the formula because you can't divide by 0. So next best thing is, why don't we just go ahead and substitute a really low ohm resistor, like 1/100th of an ohm resistor, into the formula. And if you do that, then the answer, the parallel resistance, is less than 1/100th of an ohm. In fact, the parallel resistance is always going to be less than their lowest resistor value unless it's 0 ohms, and it's going to be 0 ohms. So you can see that if the lower this resistor value is, the lower your equivalent resistor is, and it finally approaches 0.